My company develops products in the area of the wearable devices, medical devices, Internet of Things. We're a consulting company. I'm going to talk about what I've learned in working with a variety of different companies. Let's see. Okay. So first I'll talk about trends in this area, and then I'll talk about examples of sensors and applications, and then some actual innovations that are coming, and challenges with those innovations in this area. So let's get into trends. I'm going to be talking tonight about wearable devices, Internet of Things, and digital and home health. And these are all really hot areas. The wearable devices is, well, in many respects, relatively new, at least for the electronic side of it, but really hot. Internet of Things has been around quite a while and is really hot and is actually pretty big. And home health, these things have been around for a long time, and it's a growing area too. My perspective is not from surveying people in doing a marketing survey, but from actual people that are investing and developing devices. Many of these devices are not medical devices, but some of them are. Even if you're collecting data from people, it may not be a medical device. There's a low investment in the area of medical devices, so most of this is not in that area. To give you an idea of the size of the market, just in the US, there are 300 million people over the age of 5. And then I've underestimated, we're now working on a device for babies that's a wearable device. So everybody in the US has potential. For home health, there's 115 million households in the US. Now they need fever thermometers, blood pressure cuffs, and lots of other things. So a very big market. For the aging, we've got a large and very rapidly growing market. 40 million people over the age of 65 and 10,000 new ones every day. And the number over 85 is growing even faster percentage-wise. So that's a very interesting market and not really exciting yet, but it's getting exciting. A lot of people have different opinions about wearable devices. Is this just a fad? You know, next year, is anybody going to be investing in this? Does anybody really care? You get a FitBit, and how long do you use it before you set it aside? And particularly, will a middle-aged lady in Kansas ever use this? And then there are the people that say, we just need one killer app, and this will be an explosive growth area. It's going to be the biggest thing ever. I take a middle-of-the-road ground. I think we're going to see evolutionary change. Right now, wearable devices are really well adapted. Jewelry, watches, eyeglasses, hearing aids, and smartphones. I consider smartphone wearable. I've got it in my pocket. Those are really well adapted. And what we're seeing is slow changes in those devices, and I expect them to go faster. And when you interconnect them, they get smarter. So here's some examples. We've got watches, and let's see if this is, okay, I don't know if you can see the dot, but you can see watches, and well, there was a Pebble watch, now the iWatch is hot. We'll see how much that gets used. And ordinary glasses turning into things like Google Glass. Hearing aids, Sonatus has a device that goes in the mouth. I'll talk more about that later. Activity trackers that used to be mechanical devices, and now they're electronic. They're much lower cost, they're much more rugged. And then the traditional way of sensing the health of a child, the mother puts a hand on the forehead, and Scanadu has a device which does a better job of that. So I don't see any of these as being the really big thing that's going to take off and make wearables something everybody has to have, and especially that middle-aged lady in Kansas. But they're making inroads and they're becoming more popular. And with lots of innovation, we'll see a growth in this area, and I think an accelerating growth. So if you look at what's there now, there are 1 billion wristwatches sold every year. Not 1 billion in use. There's 1 billion new ones sold every year. That's pretty good adoption of a wearable device. And cell phones, smartphones, there's hundreds of millions sold every year. That's getting close to 1 billion. Samsung alone sells 1 million of them every day. Eyeglasses, hearing aids, smartphones, it's well adopted. And what makes these devices successful and some other devices not successful, sometimes some of the new ones? They need to be beautiful if you're going to wear them, particularly if a woman's going to wear them. Or they need to be inobtrusive. If you can't see it, it's okay. People try to make hearing aids inobtrusive. They also need to be functional. If they don't do anything, why do you want them? One exception would be jewelry. Its function is to look beautiful. So if you can have a device that is either beautiful or inobtrusive and is functional, I think you're going to have a success. Now, if you take something like an iWatch, it's rather large, you put it on a woman's wrist, I wouldn't say it's beautiful, and I wouldn't say it's inobtrusive, and I'm not sure if the functionality is enough to make it really hot. We'll see. Now, in the future, this is just a glimpse of the kinds of things that may be coming. There are a lot of companies making devices similar to the Google Glass, but along more narrow lines. They're narrowly focused. They're not covering a wide area. Google would like to make the Google Glass work for all kinds of applications, but many companies are making them for narrow applications. And a narrower application is more likely to succeed, and eventually, if people adapt these things, they'll be used more widely. I talked about smartphones. We'll see how well they get adapted. There's a lot of large companies making them. So somebody thinks there's a market there, and somebody's buying them. So sometimes my belief isn't what actually happens. I can't foresee the future really well. I used to have a crystal ball, but it's broken. There is a company working on a defibrillator that you can carry around on your belt. So no matter where you are, if somebody has a heart attack, you can help them out. That's pretty novel. You've got devices that fit on your ear and film where you're going. They exist, and there's a lot of work to make those better. Of course, you got the fuel band and the FitBit. Scully has an interesting device. They have, it's not yet on the market, but it's available on crowdsourcing. You have 360-degree view around you on a motorcycle helmet. If you're riding a motorcycle, turning around and looking behind you is rather dangerous. Now, just up in the corner, you have a view of whatever you want to see all around you. It could really change the experience of motorcycles, and it's built into a helmet that you have to have anyway. Things like that could make a really big difference. In home health, just to give you an idea of the kind of impact this could have, one study says that worldwide in 2025, which is not too far away now, there'll be $15 trillion spent treating chronic illness, and we could save 10 to 20% of that with remote health monitoring, and mostly that would be in homes. That's up to $3 trillion a year of savings. That's going to get people interested. You know, $3 trillion, you only have to take a real small part of that to have a really successful startup. There will be 50 million nurses doing inpatient monitoring, and we could save a half an hour to an hour every day. That's up to 50 million hours a day of savings. This is pretty big stuff. And that would be remote health monitoring. It may not be at home. Some of it would be in facilities, but there are people working on devices in this area, and there's a huge demand, and it's shown that there is savings. So things are going to be happening, you can be sure. By the way, it's been shown by the Veterans Administration that monitoring in the home actually does work and lowers cost. So if we look at what's existing in home health today, a lot of these things you'll recognize. There's walkers and blood pressure cuffs and glucose monitors and bathroom scales. Lively and other companies have devices to monitor the elderly. you can know if their activities have changed or if they've stopped. So you can keep track of someone who's not nearby. Hearing aids, things that we're used to are getting innovations like wheelchairs. So there's a lot of existing home health, and there's a lot that's going to be coming. Fall monitors for the elderly are one area where there's a lot of work. Right now, some of these exist. The one that, it's not really a fall monitor, but the one you're familiar with is, I've fallen and I can't get up. And that's just a button. It will alert somebody that you've fallen. And the people that have them generally don't use them. So the idea is you have a device that senses that you've fallen. And we have devices that can detect if something drops on the floor. Yes?
So you had a chart earlier with the old devices and the new devices, and all the new devices at least have the potential of being network connected. Is that kind of your dividing line between how things are changing?
No, not everything will be network connected in the future. The question was about the devices that are being developed. Is there a dividing line about the ones that are wirelessly connected? I think that the vast majority of the wearable devices and even most of the home health devices that are coming are wireless, are connected. It adds a lot. I'll get a little more into that. So with fall monitors, people are working on devices to detect that an elderly person has fallen, but it turns out it's not so easy. If you fall out of bed or slide against the wall, it's hard to detect. So the devices aren't working very well yet, but it's a huge problem, and this kind of thing I expect we'll see much better solutions. Activity tracking, such as the Lively device that I pointed out, there's a big need for this, not by the seniors, but by their children. If you don't live in the same state as mom, and you want to know how she's doing, and you've got some concern because there's some issues, you could call her up every day and say, Mom, how are you doing? And Mom gets tired of that. But she wants to talk about the kids. She doesn't want to talk about whether she's okay. If you had a device that just inobtrusively let you know if she was moving around in the same place as she normally did, you'd feel better. Now, Mom may not want that, because right now if you say, gee, you have this opportunity to have this device in your home that's going to track you, I don't want that. And in 20 or 30 years, I don't think I'm going to want that. But people are working on ways to make these work well, make them inexpensive, and even to make them desirable. If there's one where it will save money because it's monitoring the use of electricity. So here, Mom, here's this device that will save you money. And okay, you can install it, and if it doesn't do anything, and if it's not taking pictures and things like that. So there are advances coming in this area, and the need is huge. Alzheimer's tracking is a particular area. Each device works best in a certain area. If you've got advanced Alzheimer's, you're going to be in a facility probably, and you're going to have very different needs than if you're at home. So different devices. Medication adherence is another area. There are all kinds of medication adherence needs and devices, and I'll talk about this a bit later on. There aren't very many that work well for very many people. There's a lot of need for improvements, and there's a lot of people working in this area, a lot of companies. I think that we're soon going to see medical sensors in smartphones. I expected it this year. There are companies developing sensors that will go into smartphones that will measure medical things like heart rate and so on. I'm pretty sure we'll see them by next year. And when we have that, we're going to have apps that are collecting medical information. In fact, you can get apps now that'll detect heart rate. So that's going to change the way smartphones are used. Very interesting ways. I can't really predict, but it'll be interesting. I mentioned remote health monitoring is growing, and there's a reason for huge demand. Implanted sensors, I don't know. This is getting really out there in the future. Now, there are people who have them. If you're deaf, and certain types of deafness, you can get an implant and you can hear, you're going to want that. Now that Sonitus device I mentioned, it helps with certain types of hearing in similar cases through bone conduction, and it avoids having the implant. Now, animals get implants, and they don't think about it very much. But if somebody gave me the opportunity to have an implant, it's going to have to be a really pressing need. But how many people thought that the kids would be using smartphones and they'd be talking to each other by text messaging? So given a few more decades, implanted sensors could become popular. Who knows? So let's talk about some examples of sensor applications. I'm going to talk about these four. The FitBit, a catheter sterilizer from PureCath, the tricorder from Scanadu, and we can't leave out sports. Sports is a big area because there's a lot of money, so the golf tracker. The FitBit is based on just a simple accelerometer. It measures the change in speed. And with that, it can measure when you take a step because it vibrates or shakes with every step. From that, you can calculate the calories that are burned. It's not exact, but it gives you a good indication. It also can measure movement when you're sleeping, so you can track the quality of sleep. And it works pretty well. So you can take this one simple sensor and send the data off to the cloud, to a website, and use some software for display and analysis, and it gives you something that works quite well. A lot of people buy these. They're pretty popular. The tricorder has a variety of sensors in it. There's a temperature sensor. By the way, it's a device you hold in your hand, you hold it up to someone's forehead. So it'll take the temperature at the forehead, it'll measure the heart rate, it'll measure ECG, the heart waveform, and by measuring heart variability, it detects certain diseases, or indications of diseases. The pulse wave transit time is how fast sound moves through the blood, is a rough indication of blood pressure. Not good enough to replace a blood pressure cuff, but it's, you take a bad sensor and you take some smarts and it can help. It'll measure the oxygen content in your blood. They're claiming they're going to have urinalysis. Hasn't been explained to me how that's going to work.
It's a
separate unit. You know that? I know that. Okay, good. Glad to hear that. When you combine all these sensors and send this data off to the cloud where it can be analyzed, they'll give you an indication of stress, as well as many other things. They intend to diagnose a variety of diseases. So a lot of interesting things from these sensors. Home dialysis is an area for a certain number of people need it, and it's really critical. This is where you have a tube that's implanted in your abdomen, and several times a day you need to put in fluid and take out fluid. And I'm told that the risk of infection is so bad that everybody eventually gets an infection. And an infection there is life-threatening. So this is a big deal for those people that do this. PureCath is developing a device that is small, and you can carry it around, and it will sterilize the connection. So you make the connection, and then you sterilize it. So after it's sterilized, there's nothing that's going to touch it inside. This will change the lives of people who, they spend a half hour just making sure everything is sterile for each time they do the procedure. And it's very simple. It uses UV light to do the sterilization. So you need a sensor to detect the light, because if there's no light, there's no sterilization. And it has to detect if the enclosure is open or closed, because if it's open, the light can blind you. So a couple of simple sensors. Not such a difficult device, though it's a medical device, so it takes a lot of care. Can make quite a difference. Now, a golf game, this is an area that if you make something for golf, there's a big market. And so, you got to have something like this. This device tracks your golf game. It's got a GPS sensor in it, so it knows where you are. It has an accelerometer, which partly helps know where you are, but mainly it detects when you take a swing. Now, detecting when you're swinging a golf club from other things is a little tricky, so some clever software had to be done. And there's an NFC device. This is a near-field communication. There's a little device that sticks on the end of each golf club, and you just pass the golf club past this. You typically wear it on your belt, so you pass your golf club here, and it knows which club you're using when you make the swing. It takes all this data to the cloud, and puts it on a map of the golf course. And there are maps of virtually every golf course in North America. So by knowing where you took the swing and where you were, it knows how far you hit the ball, because you hit the ball at the beginning and end of where you hit it, right? So it knows exactly how far you hit it, where you hit it. It tracks how your golf game, and it knows which club you used. So it'll tell you some very valuable information. It works well enough that the PGA does not allow professionals to use this during a match. So not terribly difficult sensors give you some very interesting information. So let's talk about some sensor innovations. Sensors are critical to the Internet of Things. In many, many cases, they are the foundation. They're where things hit the real world. Just look at the circle here and you'll see the kinds of things that sensors are in. Innovation and a rapid use of sensors it feeds on itself. So we see the growth of sensors in things like cars, and when there's more use, they get smaller, they get lower cost, they get smarter, and then they get used more, and they get used in new things. So every time you see an advancement, it generates new opportunities and more advancements. A good example of that is in automobiles with accelerometers. They started using, well, in the 80s, accelerometers cost $100, $200, pretty expensive things. They came up with low-cost ones that could be used to trigger airbags. And how many airbags are sold every year? Even in the 80s, it was in the millions, and now it's much bigger. That generated a huge market, and a lot of research went into improving accelerometers, and now they're in smartphones. Every smartphone has an accelerometer. Those are in the hundreds of millions in sales. They've gotten so small that they're down to a little more than a grain of sand, and they cost about $1. So there's been a lot of advancements, and it took a while. It's taken several decades, but it's been a huge change. Cars have all kinds of sensors in them. Your cell phone has all kinds of sensors. So it's not just accelerometers. There's all kinds of sensors where improvements are being pushed by the demand and the market allowing for more development. What I see in the future is that home health has this huge demand in wearable devices and the Internet of Things. So where we see hundreds of millions of sensors, in the future, I expect we're going to see billions of sensors. And who knows what's going to happen with some of these sensors when we have huge markets like that. I'll try and give you some idea. So the types of sensors that we've got, temperature is everywhere. It's a very important thing to measure. Pressure, this could be air pressure. Vibration, which is accelerometers. So it's either vibration, like something shaking, or it's a change in speed when you start up and move. A gyroscope measures your change in orientation as you move around. So vibration and gyroscope go together. And a magnetometer measures your orientation with the Earth's field. Flow could be airflow or flow of a fluid. Vision from camera, I consider a camera a sensor. Microphones and photodetectors. And then you can combine them. You can now get a 3-axis accelerometer and a 3-axis gyroscope and a 3-axis magnetometer on one chip, and it costs $5. So, and that's typically what you have in your phone today, in the new ones. In the future, I think that we're going to see a lot of innovation in chemical sensors. Right now, you have chips that will detect what's in your genes, and those are getting better all the time. There's a big demand. You've also got a laboratory on a chip. These are chips that actually handle fluids, so it could take, for example, a drop of blood and move it through the chip and do analysis. There's a lot of research and a lot of development going on in there to get new capabilities. And we have some paper disposable sensors. A typical one would be for measuring glucose or for measuring pregnancy. And there are people working on many more types of chemical sensors that would be paper-based. So the disposable part is very inexpensive. Fiber optic sensors is an area where there's a lot of potential. They measure pressure, temperature, strain, force, displacement, a lot of parameters. I'll talk about it more in the next slide. There's been a huge amount of work in the area of non-contact glucose sensors. When you got to prick your finger with a pin several times a day, and particularly if you're a child, if you could do that without pricking yourself with a pin, it would be huge, huge market. More than $1 billion has been spent in development, and we don't have it yet. So I'm not counting on that one to happen anytime soon. Big data is going to be used to analyze all this. That's what a lot of you guys do, and you can bet there's going to be a lot more of that. The sensors all have limitations, and when you apply software and make them smarter, you get some really interesting things happening. You can overcome some of the limitations. For example, if you have an accelerometer that, well, think of a GPS. If I move a short distance, it may tell me I moved 30 feet. And then if I move 30 feet, it may tell me I barely moved. But if I take a number of readings, I can get a trajectory, and I'll get an accurate reading of what I did, even though on a short span of one sample, it may not be very accurate. So software can make that happen. So if we look at fiber optic sensors, they're very safe compared to electronic sensors that have wires because they don't conduct electricity. You can't shock the patient, which is a big issue. And they're very small, a really small diameter. They operate in environments that other electronic devices would have trouble with. And you can even have multiple sensors on one fiber. So they seem ideal for all kinds of things, particularly in the body. The biggest disadvantage is the cost of the electronics. Right now, it's about $1,000 for the electronics that goes with a fiber optic sensor. You're not going to see that in a cell phone anytime soon. There's enough demand that I think this development is going to be happening, and we're going to see what's happened with other sensors where increased demand, increased use of them, and more development is going to lower the cost of the electronics. Electronics is an area where development can make things cheaper very quickly. Let's talk about some of the challenges. So when we're talking about wearable devices, what I see is the &1 challenge we deal with on every device is the battery. And batteries are not going to change very quickly. And I'll talk about more of that in a minute. So another one is sensors. Sensors all have limitations. When you're dealing with home health and the elderly have unique needs that I'll talk about. Healthcare providers are slow to adopt new things. And then there's the islands of data, which I'll talk about. And then people create new devices, and sometimes they make a medical device and they don't know it. That's an issue. And then the regulations, particularly around medical devices. So let's talk about batteries. If battery technology advanced like semiconductors have, you would have a device the size of a pinhead that could power your car and it cost a penny. And we're never going to have that. If you want to get much, much denser power than we have in a battery now, you could use nuclear. And I don't think we're going to see nuclear in a wearable device anytime in the future that I can predict. So you're limited by the storage capacity of chemical energy. And we're making progress. Every year it gets a little better, but it's not going to get double in next year. So that limitation will remain indefinitely. So you got to work around it. You've got to trade off between how long between charges and how small the battery is, which determines, in many cases, the size of the whole device. The other thing you work on is how far are you going to transmit. If you've got a wireless device, if you transmit to your cell phone in your pocket, it takes a lot less power than if you're transmitting to a cell tower that's several miles away. So the type of transmission will determine the power that's used. You can also operate something in short bursts. So if you've got a small amount of data, you don't have to have the transmitter on all the time. You collect it for a while, and then you turn it on, send a bunch of data, and turn it off. And then you can use devices that are lower power. For example, GPS is it's moderate power. If it's on all the time, it's going to use quite a bit of battery during the whole day. An accelerometer uses a lot less power. In fact, if you combine an accelerometer, accelerometer and a gyroscope and so on, you can keep track of where you are for a while. Eventually it gets errors. So you could turn on the GPS every now and then and make a correction, but in the meantime, you could use a lower power device. Yes?
So there are watches powered by the movement of your arm. There are watches powered by light. I think there probably are ways of generating power from the heat coming off your body. Are there other ways besides batteries being looked at?
So the question is about energy harvesting from heat and movement and other areas. Energy harvesting generates power in the milliwatts and microwatts. And most useful devices that are being sold today are in the tens of milliwatts and hundreds of milliwatts. So energy harvesting isn't useful for most of the wearable devices. I wish it were, and there's definitely work going on there. And it depends upon what trade-offs you're willing to make. If you're willing to have a simple device that's not very powerful, doesn't send doesn't send the information very far in distance, you could use energy harvesting. So low-cost devices are not very accurate. The low-cost accelerometers aren't very accurate, but if you're just detecting whether or not there's an accident, you don't have to be very accurate. They have problems with linearity and offset, so they don't change as you would expect. You can correct for many of these errors by doing calibration, but that's typically something you do at the factory, and it costs time and money. There are devices that auto-calibrate. For example, if you know what 0 is, if you know when you're not moving, you can say, okay, this is 0 motion. Or if you know the temperature at a particular time. Or if you only want to know the temperature change, then you don't have to worry about the absolute. Getting good data can be a problem, but with well-designed electronics, it's less of a problem. And the software, as I mentioned, can make a big difference in making the sensors, in overcoming limitations of sensors. With cameras, with vision, the biggest problem is usually lighting. And if you've ever taken a picture, you're probably aware of that. When you're using a camera in the body, it's a particular problem. You have to bring your light with you, and in many other applications. So if you can get enough light, that's good, but light takes power, a lot more power than the camera itself. So the limitation of some camera applications is in the lighting, as far as the power usage. Let's talk about the special needs of the elderly. It's a really hot area, and the limitations and the problems there are different from many other areas. First of all, we're talking about many devices that are not paid for by insurance. So who's going to pay for them? Well, I mentioned that this activity monitor probably won't be paid for by mom. It turns out that the children are the ones that are usually paying for these devices, and usually not with insurance. These devices have a stigma. I can remember when my father was in an elderly home, and he was going around on his walker, and he said, well, I'm not sick like these other people around here. He didn't want to be sick, and I understand that. If you can make a device that's really cool, then it becomes desirable. So there's a company that makes canes in a variety of colors, makes them really interesting. So if you're going to sell to the elderly, make it cool. It's also got to be incredibly easy to use. And, has your cell phone ever worked differently today than it did yesterday? They're designed to have really cool features, but they're not real easy to use. And lots of things where they're working on giving you the latest in technology, the ease of use is lacking. With the elderly, it's critically important. They've got perhaps less, the brains aren't working as well, the eyesight isn't as good, hearing isn't as good, the sense of touch isn't as good. And the elderly are less patient with something that isn't going to work. They're not interested in it because it's a cool electronic device. So if it isn't absolutely dead easy to use, that's a problem. Now, there are devices that don't actually solve a problem in this area and others. But particularly in this area, many of the developers are young, and don't understand their customers really well. And if you don't have it meet the needs of the customer, it may not actually solve a problem. I see many companies come to us and would like to have us develop something, and when I ask about the customers, they don't really understand the customers so well. So that's really important. There's a huge opportunity, and I don't know if a device can do this. Big problem with the elderly is isolation and loneliness. As you get older, you may lose your spouse, you may lose the ability to drive, you may be put into a facility where you've lost the contact with your friends. You're isolated and lonely, and you lose a sense of purpose. Now, for the people here, you're probably so busy it never even occurred to you to have a problem with a sense of purpose. But when you have somebody taking care of everything, there's nothing that you need to do. You don't need to take care of anybody. The isolation and loneliness is the cause of much of the health problems of the elderly. So if we could solve these problems, it would make a huge difference. Now, if some smart person can think of some way, some device or some technology that could solve this, that would be huge. A dog. Well, actually, we've discovered that people and the elderly actually are attracted, or they form bonds with machines, with robots. There was one study where, I've forgotten some of the details, but they had a device that was it was a head that moved and its eyes moved, and they put it in place with a number of the elderly as a test. And when the test was over, they came to take them back. And they found that they had been dressed with clothes. And when they came, the people said, "No, are you going to take my friend?" So yes, electronic animals can help with loneliness, absolutely. Real ones work too, yes. So let's talk about the adoption of new technology by healthcare providers. When doctors go to medical school, they're taught the standard of care. This is a standard which you need to meet in order to guarantee that people are getting proper care. It also protects you from lawsuits if you meet the standard of care. Changing the standard of care takes a long time. There was a treatment for phlebitis that was introduced sometime around 1960. And it took phlebitis from 50% fatal to hardly fatal at all. It took about 20 years to be widely adopted, to become the standard of care. A lot of people died waiting for that. On the other hand, there are devices that get introduced into the market that cost more and don't help, or sometimes they turn out that they actually have less capability or less efficacy than what's out there. And we don't want to adopt those devices. So how do we change and adopt the right things and not the wrong things? Yes, there's a question back here.
Which classes of device are subject to the FDA approval process and which ones aren't?
You're saying, are these devices subject to FDA approval?
What classes of device are subject to FDA approval?
Which one?
Which classes? I'm going to talk a bit about that in a minute, but there are devices that have been approved by the FDA and drugs that have been approved, you've probably heard about, that turn out to have problems and are not as good. We'd be better off not using them.
Just a side point, it turns out you have to go on and maintain that it's a medical device, then you're going to get to the FDA. A FitBit, for example, or if you look at some of the stuff that's done by Nike, they don't say you burn calories, they say you go on and burn Nike energy units. And as a result, since it's not a calorie that you're burning, and you're not making claims that you're burning calories, they go on and sidestep a lot of the FDA approval process.
So I've got a slide about what's a medical device. So if you want to introduce something that's going to be used by doctors and adopted by doctors, how do you overcome the inertia there? One of the best ways is to make it easier for the doctor. And a good example is two things that were introduced in 1846. One of them became immediately used and the other isn't widely used today. Can you figure out which is which? Anesthesia became widely used within months. because it made doctors' lives easier. Their patients weren't screaming. Hand washing, you still see doctors that fail to wash their hands. And it doesn't make the doctors' lives easier. It sure helps the patients, though. Yes?
So if you've ever talked to a doctor who worked for a large institution and now has to record all of their notes on a keyboard and complain about how a pain it is, there have now been articles in medical journals that have decided or surveyed that if the doctor has someone following them around who does the typing for them, they are more efficient.
That makes sense.
Yeah.
So if you couldn't hear that, there was their device. They found that if you have somebody following the doctor around and taking notes rather than having the doctor do it, the doctor's more efficient.
They hate to type.
Yeah, there's one thing that you're not mentioning here. I actually put together a device, showed it to a doctor, and basically I said, look, this person that died before isn't going to die anymore. Would you like to try this thing? Yes. Well, one simple question, and that is, does the insurance pay for it?
Yeah.
And that was in terms of adoption. The other question that comes up is not whether it makes it easier, it's whether it gets compensated by the plan.
Another factor is liability. If you take your medical information into the doctor and he looks at it and misses something, he may be liable to having missed some problem.
So just a couple more.
Yeah. There's a lot of things that can go here. I think making their lives easier is at the top. And I heard this from doctors, a group of doctors. So let me talk about the islands of data. This should be very applicable to what you're doing here, what many of you do. The devices, the wearable devices, the home health devices, many of them are putting data into the cloud, but it often goes to an isolated website, and it's difficult to share. So it can't be transported to another website. It's difficult to give it to your doctor. Or another example is if I'm using a FitBit and I switch over to another device, the information is going to be on another website, and I don't have a record of what I did with the previous device along with the current data. It's all separate. And if I'm using multiple devices, I want to measure my blood pressure, my temperature. How do I get them all into one place rather than going to different places for each one? There are people working on solving this problem to be able to collect information from a variety of sensors or from a variety of places on the internet. The problem we have then is if that data is an electronic health record, then it's subject to a lot of regulations. Now, if I collect data about my health, that's not an electronic health record that's protected. If I collect data about your health, that's protected. And I have to be very careful how I store it and share it. So, and HIPAA is dealing with patient confidentiality, which is about health records. There's severe penalties if you violate this. So you've got to be very careful how you're handling this data, and yet we want to overcome the problem of islands of data. So it's not simple. So let me talk more about making a medical device. A cell phone app can be a medical device. Now the FDA tried to make this definition a little easier. They issued guidelines particularly for apps last year. It's still not totally clear. You know, I look at the definitions and gee, I'm not sure. You know, what does this word mean in that definition? You really need an expert in order to know for sure. And if you make a mistake, if you make it something that is not, that's a medical device, and you don't go through the proper procedures, you may get a letter from the FDA that says, show us how you have shown that this is not a medical device. And if you haven't done anything, they may send you a letter that says you've got 30 days or you've got to stop selling this. That's pretty serious for a small company. They do tend to be generous and easygoing with small companies, but you know, you don't want to get in the way of the FDA. Now, there are simple ways to get around this, as one person in the audience mentioned, by changing the instructions. There's a pulse oximeter. This is the device in the hospital you put on your finger, and it measures your pulse and your oxygen content in your blood. The very same device is sold to medical professionals as a medical device and sold to the public as not a medical device. And what has changed is the instructions for use, the instructions that come in the package. So the one that's sold as not a medical device is not for diagnosing any disease. It's not for any medical use. I don't know exactly the wording, but if you word it right, it's not a medical device.
It's for entertainment only.
Something like that, yeah, something like that. So which of these devices are medical devices? The fuel band is not a medical device. Now, if they made a claim that it would actually do certain things to improve your health, that would make it a medical device. A fever thermometer is a medical device. It's a class 1 medical device. You actually have to register it. The Scanadu tricorder will be a medical device. They're claiming that they're going to diagnose disease. The monitor for the elderly is not a medical device. It just reports on activity. Zosano has a patch that has drugs in it that you apply with an applicator. And that's a device with a drug. That's a highly regulated device. Azumio has an app on a cell phone that reports your heart rate. And I know doctors who use that. Is that a medical device? It's, I don't know. I don't know if they ever thought about that when they created the app. We've got a problem with regulations in some cases, as I pointed out with the islands of data. How can we make things easy and not create problems? You know, the HIPAA was put in place for a good reason. People don't want all their medical data shared with everybody else. I don't have a solution for how to solve that. This is a matter of government, which is slow moving, and technology, which is fast moving. The definition of a medical device, if it's difficult to decide, do we need to change this, or can we change it? And then look at things like the tricorder. You know, a few years ago, did we ever think we'd see a tricorder in our lifetime? And now Scanadu has something, not exactly what you see in Star Trek, but it's getting pretty close. Things are changing pretty rapidly. These are questions that I don't have answers for how to take care of the regulations. So we've taken a look at changes in home health and wearable devices, and I'll take questions now. Yes?
Did you see any trends with respect to data privacy, especially in the health wearables?
Okay. So the question is, have I seen trends in data privacy in the health area?
Right, like policies or, you know, does
Okay,
anybody
policies.
apply something or what's happening?
I haven't seen any changes recently. There could have been some that I haven't seen, but I haven't seen changes in that area. HIPAA has only been around for not a long time. I haven't seen changes in that area. Yes?
So medical is certainly important, but it's much broader than that. So for example, there was just an agreement between the major car manufacturers who now with their new cars can record where you are, where you go, how fast you go, how long you spend there. And they've agreed to some limits on how to divulge that information, and they've agreed that they will only divulge it under a court order. Nonetheless, they suddenly have a tremendous amount of information about your life.
Yeah.
Think about all the other devices in your home that will eventually have sensors and be wired. I mean, your refrigerator, your washing machine, every time you buy a 6-pack of beer, does your refrigerator tell you, record that and send it to some marketing firm? I think, I don't know, it's hard to read anymore how sensitized people or desensitized people are to all this data because the amount is just exploding.
So the comment is that the automobile manufacturers have agreed to limit the amount of data that's available because their cars are collecting so much data on you.
But they didn't agree not to use it to market stuff.
Yeah, well, we have the same issue with cell phones. And with the Internet of Things, the thing I worry about is somebody somewhere else in the world will know if I'm home or not. That makes me nervous. Question over here.
You know, one of the car manufacturers aren't limiting some of that by choice. You know, just recently they had a feature which would watch, if you give your car to somebody else, it would tell you what they did with it. And that ran afoul specifically of California anti-wiretapping law. And several other states have laws against wiretapping. You know, it's interesting.
Now there are people working on devices that will monitor your children when they drive. if it's your children, maybe it's okay. The question was, or the comment was about wiretapping. If you are tracking somebody else using your car, you may be violating the wiretapping laws. Question over here.
I was just going to make the comment that there's a whole bunch of large major companies that will be coming out with products where the privacy will be a feature of the product. So you'll get this product from us and the data will be handled in a certain way that's different than ours.
Unlisted numbers.
Yeah, so comment is people are coming out with devices where a feature is that it limits, that it improves your privacy. They will limit the amount of information they send out.
Right here. Could you talk a little bit about where you see the aggregation of this avalanche of data going? So rather than being centralized, or is it, are you going to have multiple processing stations, or where do you see?
All right. So the question is about what's going to happen with the data that's being collected in the cloud. Is it going to be centralized or is it going to be distributed? Certainly, centralized data is big and growing rapidly. And one of the biggest drivers is for marketing. The people that are selling products want to know where you are, who you are, and what you're doing. And all these sensors and all these wireless devices are making that more and more possible. But there's also people interested in knowing about themselves. And the data is going into the cloud to know what you're doing yourself, or what your kids are doing, or what your pet is doing. And this data you may not want to share with others, but you may want to have it available for you and maybe for select others. So there's also a growing area where it's not going to be available to everybody. Does that answer your question? Or does that cover it?
Yeah.
Okay, all right. Yes.
What percentage of your revenue comes from this kind of stuff?
Most of it. This is where we're working. This is a really hot area, and there's a lot of development going on.
And in that, how would you break it down between medical and non-medical stuff?
Well, for us, for my company, we do about half medical and half non-medical. In the back, there's a question.
So, actually, it's not a question, it's a comment. You were talking about cars and sharing data and whatnot, the other people being able to see. We, the ACM, ran a hackathon with a large car company not too long ago, in the last couple of years, and they were certainly aware of the issue, and so there are the typical kind of things that you would see, like you see already on any social site, where you can choose to share data with other people or not. So I think a lot of the car companies are aware of that. You don't need to be too afraid of it.
Okay, so the comment was that a lot of car companies are giving you the option to choose whether you share your data and providing some protection. Yes, in the back.
You were talking about whether people are concerned about privacy. Even before that, though, fairly often it turns out devices have regularly, they do like hackathons and find out that, oh, there's no one ever worried about security of the thing, and it will be broken wide open in half a second. Instead of worrying about privacy, I mean, we want that after we know that it's actually not going to be broken wide open first.
It's just as secure as the...
Yeah, so the comment was about security as well as privacy. Devices can be hacked in very quickly. What we're starting to get news about is utilities being hacked. Utilities have been putting in Internet of Things connected devices for a long time, and 20 years ago people didn't worry about security. Those devices are still there. You may have remembered reading about the virus that was specifically targeted at certain devices in Iran that were creating nuclear energy or the nuclear fuel. So people are starting to have warfare by breaking into the Internet of Things devices. And there's a very strong potential that somebody could shut down our electric system, for example. Having no electricity would really be a big deal. Yes, right here.
So That kind of segues into this question, which is I've seen some white papers at least, or research papers, and people are starting to look at sensors to map biometric authentication for security. Have you seen like a major trend in that? Is that market ready?
Okay. So the question is about biometric sensors for security?
Beyond just thumbprint, I've seen like people measure ear canal, like all kinds of different stuff.
The one that is well adopted is the finger. Even in an amusement park, they'll use a fingerprint to identify you. I don't see a lot of development in that area. There's some, but I'm not seeing a lot going on in that area. Yes?
Do you see a convergence in the wireless interfaces at the level of the sensors? Is it BLE or is it Zigbee, or do you see any convergence?
Okay, question is about convergence in the wireless area. And when you say convergence, you mean ending up with one standard instead of many? Okay. In some respects, I think there's a convergence. I think that Zigbee is becoming less popular and Bluetooth is replacing it, particularly with Bluetooth low energy. The main reason that Bluetooth is more popular than Zigbee is because it's on every cell phone and every computer, or at least every new cell phone. So if you're going to do something in Zigbee, you've got to have a receiver and a transmitter. And that's a big deal if you got a single device. There are certain markets where Zigbee is popular. Now, as far as things like how far you're transmitting, you've got cellular that transmits at long distance and Bluetooth that's a short distance, and Wi-Fi is in between, and their power and power consumption is proportional to that distance. We're not going to see a convergence there because power usage is the #1 problem. So you're always making a choice between, do I have a small battery and use something like Bluetooth, or do I have a larger battery and a short life and transmit a long distance for cellular? There's no convergence happening.
I have a quick question. You see all the debate going on about cell phone data collection. Do you anticipate that kind of thing will happen with our sensors data collection?
Okay, question is about cell phone data collection. We see a lot of cell phone data collection. Will it happen with sensors? Undoubtedly, because there's the demand for it. It can be used to market to you. And it can be used by criminals, unfortunately. By the government. Well, yeah, that's a big issue. Yeah. Yes?
Are there any smell-related sensors coming up?
Any what?
Smelling.
Oh, are there any sensors that detect smell? There are people working on devices that put out smells so that you can basically have smell-o-vision. Not for that application, but there's work in that area. Detecting smells is much harder. I'm not aware of much going on in that area. There's some, but nothing really hot that I'm aware of. Oh, smoke detectors. Okay, a little different.
Yeah, you didn't mention anything at all really about, you did touch briefly on it in fiber optics, but you didn't mention anything about spectroscopy in a lot of the stuff you talked about. Have you seen any kind of low power, low footprint, low cost spectroscopy solutions coming in on the sensing side?
There's a lot of work going on. The question is about spectroscopy. Are there going to be, is there low power, or what was the other? Low cost. Low power, low cost spectroscopy devices. There is a lot of work going on in spectroscopy. That's a good area to mention. Spectroscopy is detecting light, typically the different wavelengths of light, and you can do it pretty cheaply now. Sensors are pretty inexpensive, and it can be used for quite a wide variety of applications. There is a lot going on in that area, and that's an area where I do expect there's going to be quite a bit of innovation that will be coming out. Yeah. Yes, in the back. Question is about using beacons for shopping. And what else? Microlocation data.
Once the microlocation capture, there's a lot of data mining and
yeah. So once you've got one of the devices out there, there's a lot of data mining that can happen. These devices are becoming popular, and you may be totally unaware that they're in use. If you're in a store and your phone gives you an advertisement, and you happen to be right in front of something, then you've got one of these devices that's talking to you. Now, typically, and I think so far in every case, you have to put an app on your phone before this is going to operate. So you have to actually opt in. This is something that marketers really want to do. They want to give you have a discount if you'll buy that thing that's right in front of you right now. So the micro locator is a really big thing. And is it going to get used in ways we didn't anticipate? I would expect it will. I don't know what ways those might be. Yeah.
I was wondering if you had a wish list. So at this very time, there's a group called the IEEE MEMS and Sensors Group, and they're busy inventing new MEMS and sensors. I was wondering what your wish list for MEMS and sensors was.
Okay, so the question is, what's my wish list for MEMS and sensors? And that's easy. Most of our problems would be solved if everything drew less power. And then the batteries could be much smaller. And we wouldn't have batteries, we'd use energy harvesting. That's number one. The next one is everything should be smaller. No matter how small it is, people want to make it smaller. We had a company approach us about putting devices in a ring, and, a ring that you wear on your finger. A little bigger than the one that I'm wearing, but that makes a watch seem gigantic. So yeah, smaller and less power, every device. Yes?
Do you think sensitivity, whether justified or not, to RF transmitters next to or in your body is affecting things?
Okay, so the question is about, is it an issue about the sensitivity of devices to transmission?
No, people concerned about it.
Oh, okay, about people.
Adjacent to their body,
Yeah.
or ring, or inside their body.
Okay, so about people being sensitive to these transmissions. So it's a bit of a complicated answer. The biggest issue has been over cell phones because they dissipate, they send out the most energy, a lot more than Bluetooth, for example. There have been many studies and the studies have largely shown that there's not a problem. There's anecdotal evidence that there may be a problem, and people are worried about it. And sometimes studies are wrong. So you can't be 100% certain that there isn't a problem. It doesn't appear to be a real big one. And then when somebody I know dies from brain cancer right next to where he used his phone all the time, it makes you wonder. So yes, it's an issue. People are worried about it. And a really good example is when somebody wants to put a device on a baby, they don't even want to have Bluetooth because it's putting out RF. And people are really concerned about babies. So it's something people are concerned about, and yet it's not clear that there's anything that needs to be worried about. However, if you think about the amount of power that's been put out by a cell phone, seems like there could be a problem. A lot of it's absorbed by your body. Any other questions? Okay, well, thank you very much.